All right, today we're going to be looking at the next method of solving quadratics called the square root method. The nice thing about the square root method is it's the one where we don't need the equation that we have to equal 0. And what you're going to find is this is the method we want to use when there's not a b term or there's not an x value in and of itself, where we have a squared portion and we have a numerical or a constant term. So we're going to have a few steps in there. The first thing that we want to do is we're going to isolate whatever is squared. So anything that is a part of the squared is going to get left on one side, and we're going to move everything else to the other side of the equal sign. After we've done that, then we're going to square root both sides of our equation. Now, we've not really focused on this before, but when you square root a number, the truth is it has a positive and a negative value. We've really only focused on the positive value of a square root, but the truth is the square root of 9 could be 3, and it could also be negative 3, because a negative 3 times a negative 3 would also equal a positive 9. So when we're talking about solutions to quadratics, because we're talking about a number line or on the coordinate plane, we can have a negative or a positive answer. So we've got to deal with both of those. And when we square root both sides, it's going to get rid of the square on the left side, and then we're going to get a square root value on the right side, and then from there we're going to solve for x. And so I'm going to look here at 6 examples that you might see varying in degree of effort needed or steps needed. So if we look at number 1, we have x squared equal to 9. And if I go to the left side, everything on the left side, which is just x, is squared. And on the right side, we have a constant, which is 9. And so this is exactly how we want it to be set up. In this case, we would move straight to number 3, which says square root both sides of the equation. So we're going to square root both sides of our equation. I'm going to put a square root over x squared and a square root over 9. The square root of x squared is x. And again, the square root of 9 is either a positive or a negative 3. So we would say plus or minus 3. Now, because it's just x, there's nothing more that we need to do. So here, our solutions are 3 and negative 3. And so we're already finished with that. We didn't have to do any kind of moving around. It was just one of those that was set up the way that we needed it to. All right, looking at number 2, we have 5x squared, and that's equal to 80. Now, a thing to keep in mind, and a thing that students get confused about, is that the square in this portion only is only on the x. It is not on the 5. So the first thing I need to do is isolate what's squared, so I need to get rid of the 5. And the way that I'm going to do that is by dividing by 5. So I'm going to divide both sides of my equation by 5. 5 divided by 5 is 1, or simply x squared. And then 80 divided by 5 is 16. Again, now that I look, I've got the value that is squared all by itself. And so I need to put a square root on both sides of my equation. So x equals, and then the square root of 16 is 4, so it's positive or negative 4. So in this case, our solution would be 4 and negative 4. So really that one was just a two-step issue there, nothing terribly complicated, but again, we're trying to isolate whatever's squared, and then from there square root and move on. All right, let's look at our third example. In our third example, we have 3x squared plus 5 equals 80. So I've got to move anything that's not squared to the other side. And so we're going to treat it just like a two-step equation. And the first thing I'm going to do is I'm going to move the 5. So I'm going to subtract 5 from both sides. So we have 3x squared equals 75. All right, and then my second step, again, is I'm still working on isolating what's squared. Again, x is the only thing squared. So my next step is to divide by 3. So in this case, x squared equals 25. All right, and now I'm to the point where the squared value is on one side, and the constant is on the other side. So I'm going to square root both sides. Again, the square root of x squared is x, and the square root of 25 is plus or minus 5. So my solutions are 5 and negative 5. All right, so far it's been pretty straightforward. We've just been able to square root and come up with an answer. But if you'll notice on 4, 5, and 6, they look a little bit different. All right, so let's take a look first at number 4. It says x minus 6 all squared equals 81. All right, so when we have this situation, in this case, the whole entire binomial is squared. So when we do, so everything right now on that left side is part of what's squared, so we don't have to move anything. So what I'm going to do is I'm just going to simply start with a square root on both sides. Now, if we use the logic that we used on example 1, the square root of x squared was x, then the square root of x plus 6 or x minus 6 all squared is simply x minus 6. And then that would equal either a positive or negative. In this case, the square root of 81 is 9. So x minus 6 equals a positive 9, and x minus 6 equals a negative 9. So we need to solve both of our equations to get x by itself. So x minus 6 equals 9, and x minus 6 equals a negative 9. I'm going to add 6 to both sides. So over here we have x equal to 15. Over here I'm going to add 6. And so x equals a negative 3 because negative 9 plus 6 equals negative 3. So in this case, our solutions are 15 and negative 3. All right, going to number 5, we have 2x plus 5 all squared, and that is equal to 100. Again, because the entire thing is squared, we're going to simply start with a square root of both sides. So I'm going to square root both sides of my equation. So now 2x plus 5 equals a positive or a negative 10. So again, I'm going to set it up where 2x plus 5 equals 10, and 2x plus 5 equals a negative 10. I'm going to subtract 5 from both sides. So now 2x equals 5. And divide by 2. So x equals 5 over 2, or 2.5, or 2.5. All right, on my other side, I'm going to subtract 5 on both sides. So I'm left with 2x equals a negative 15. Divide both sides by 2. X equals a negative 15 over 2, or a negative 7.5. So it's 2.5 and negative 7.5. All right, looking at our last one, we're going to look at our sixth and final problem here. We have 3x minus 4 all squared, and that is equal to 7. All right, so I'm going to put a square root on both sides as we've done the last few times. So this side is equal to 3x minus 4. The difference here is that 7 is not a perfect square. So we have a couple of options. Sometimes on an assignment or a test, the square root is left there with the number inside it. So in this case, we're going to start with a plus or minus the square root of 7. And we're going to leave it that way for right now. So we're going to say 3x minus 4 equals the positive square root of 7, and then 3x minus 4 equals the negative square root of 7. All right, and then we would simply solve as we always have, add 4 to both sides. So then we would have 3x equals, and because the square root of 7 hasn't been solved, we have to leave it as square root of 7 plus 4. Then we would divide both sides by 3. So x equals the positive square root of 7 plus 4 divided by 3. Again, we would do the same thing to the other side, add 4. So in this case, we would get 3x equals the negative square root of 7 plus 4. And then we would divide both sides by 3. So x equals the negative square root of 7 plus 4 divided by 3. And we could leave both of them like that. That would be acceptable. If it was a situation where we had to put it in a decimal, we would probably round that decimal to the nearest tenth or hundredth. So you could go to desmos.com/calculator. You could start with a fraction and then type that in as you see here, and you would get an answer of 2.21 rounded to the nearest, or 2.22, excuse me, rounded to the nearest hundred, and then rounded to the nearest hundredth would be 45 hundredths. So our two solutions to rounded to the nearest hundredth would be 2 and 22 hundredths and 45 hundredths. Or again, you could leave it as positive or negative square root of 7 plus 4 divided by 3. Hopefully this helps. Again, this is really beneficial when we don't have an x value, when we've got a squared item and then a constant or our c value, but not the b value. If you have any questions, let your teacher know.